This is GitHub Spec Kit. It's a new project that's supposed to allow you to build higher quality software faster with AI. In this video, we're going to talk about what Spec Kit is, what it does, how it works, and we're going to try to build something with it. Let's go. Now, you can find Spec Kit on GitHub's own repo here. So it's just github.com/github/Spec Kit. And then if you scroll down and we look at the README here, let's just kind of walk through this together. So Spec Kit says build higher quality software faster, an effort to allow organizations to focus on product scenarios rather than writing undifferentiated code with the help of spec-driven development. So spec-driven development flips the script on traditional software development. For decades, code has been king. Specifications were just scaffolding we built and discarded once the real work of coding began. Spec-driven development changes this. Specifications become executable, directly generating working implementations rather than just guiding them. Now, if I was going to distill all that down in my own mind here, there's two things that I take away from this. One is that I've never really built applications with specifications. I think it just depends on where you work, but generally I was given very vague requirements and then I had to come up with them. And the way that I work is very iterative. I build, I figure something out, figure something else out, add another feature, and the documentation comes later. Because you don't know what you don't know. You can't know everything up front. You build as you go. Specifications are the reverse of that. We're going to define the whole project up front, and then we're going to generate the artifact. The problem with specifications, though, is that they become out of date pretty quickly. As you move through, you realize some things are going to work, others aren't. And you use the specification to sort of guide the project, but what you get in the end is totally different. So by flipping the script, we're saying that the spec now is the asset that we're actually after as human beings here. This is what we're actually interested in. And Spec Kit defines the code as the expression of the specification. So in this odd way, we're now more interested in the spec and actually less interested in the code or the output. Very strange way to think about things, but that's kind of where we are. Now, how do we get started with this? Well, to get started, you need to install Specify, and it uses this UVX tool. If you don't have UVX installed, you can install it here from Astral's site. It is a Python installer. It's got Windows. You can see PowerShell here. That's what I'm using. And of course as well, Linux and Mac OS. So let's grab this and let's go ahead and try to get started with this. Now, it looks from this like you need to start a new project here, but that's not actually the case. You can run this in an existing project, and that's what we're going to do because of what we want to build here today. And that is this site that I have called the URL list. Now, if you've watched other videos, I try to build this site all the time. I use this over and over and over again to test different models and different tools. And the reason why I do this is because it's a fairly simple site. It just allows you to create and share lists of links, right? It is quite literally just a list at the end of the day. It is complex enough because it includes a database and it has several screens in it. But it is simple enough in that we can actually look at this together and not build something that's so complex that you have no idea what we're actually building here. So this is what we'll be building. And I've gone ahead and started off and tried to give this thing every benefit that I could. So I've created a project here using Next.js and ShadCN UI. And the reason why I've chosen those technologies is because they're very opinionated. And LLMs really like opinionated frameworks because they know exactly what to put where. They don't have to make any decisions on their own. And that's good because we really don't want the LLM getting creative with how it structures and writes our code. So let's just paste in our command here and then we'll go from there. For the project name, we're already in a project here. We already have a project name. The URL is Spec Kit. So I'm just going to remove that argument and init, and hopefully it will put it in we need to specify a project name. So maybe we just do the directory already exists. Okay, so it does need a subdirectory. So let's just we'll just call it Spec Kit. And that should put it in a folder inside of our project here. Now you can see we have the choice to use different AI tools. We're going to use GitHub Copilot and we're using PowerShell. This is important because it does generate some scripts that it's going to want to run. And so it needs to know what terminal we're using or what shell. Now, next steps, move into that project, open Visual Studio Code and use specify plan or task commands with GitHub Copilot. Update constitution.md with your project's non-negotiable principles. Okay, what is all that? Let's take a look. So let's open up our sidebar here and take a look. So Spec Kit is the folder that we got. And inside of Spec Kit, we have a specify folder and we have a GitHub folder. Now, what I'm going to do is I'm going to move these folders just to the root because I don't think we need them in a root folder here. So I'm going to delete this Spec Kit folder and I just move these two dot folders to the root. So we have a GitHub, which has those 3 prompts in it that it talked about, right? Plan, specify, and tasks. And then in the .specify folder, we have 3 subfolders. The first one is called memory, and this is where you find that constitution. So let's start there. The constitution is essentially the instructions that you have for the model about the way that you work in your projects that are non-negotiable. By default, it's given some placeholder text here, but there isn't really anything here. And because I don't really have any of these things yet, we're starting from 0, I'm just going to open the chat and I'm just going to ask it to update this constitution file with non-negotiable principles for development with, and we're using Next.js, we're using shadcn UI, and we're using Postgres as the database, okay? And let's just let the LLM come up with our constitution here. We'll take a look at it, and then we'll go ahead and move forward. Okay, I skipped ahead there, but it's updated the constitution. Let's take a look at what it's given us. So it's pulled out all of the placeholder stuff, and then it's gone through and said, so every change must serve an explicit user outcome, remove, do not generalize. This is for simplicity. This is at the app router. So you can see here schema changes, migration first, drizzle, or Prisma style with forward compatibility. So actually, I don't want that. So let's go here and let's pull what's our constitution. And for the database, so I don't actually want this. I don't want it to use an RM. I'm just going to have it use the standard Postgres driver, no ORM. And then we'll just let it update this section of our constitution here. All right, so now we're just using straight up Postgres. Security and baseline privacy, least privileged DB roles limited to required statements, no application super user in production, secrets only from environment, process.env. Yes, all of that looks good. Observability and operational readiness, structured logging, performance and edge strategy, use server components and streaming where the payload is greater than 40 kilobytes or waterfall risk. I'm not even sure what waterfall risk is here. What is waterfall risk? Now I'm curious. Now I want to know. Sequential data fetching or rendering causes cumulative delays. Interesting. I had not heard of that before. So that's waterfall risk. Images through Next.js image component. All of this looks good. Avoid client state libraries. Great. Testing and quality gates. Test pyramid. Fast unit and component tests. Okay. Branch review and CI enforcement. No direct commits to main. This is interesting. Part of the way that it handles branching for you is going to be quite interesting. Documentation and traceability. Every exported module, top comment, purpose, invariant, ownership tag, migrations. Again, I don't know. Some of these things, I just don't know what they are. I don't know what invariance is here. Additional constraints and standards, TypeScript strict only, lint rules, import layering, app/ can import lib/ but not vice versa. UI components consume pure functions. No direct DB calls and client components. This is really good. Like these are the kind of details that if you don't add, The LLM will be happy to make direct database calls from you from client components, which is going to expose your keys. This is really good. And this is the point of spec-driven development, is that it catches the things that you don't catch, or the details that you should have given the LLM, but you just didn't think of because you didn't think that they would do this. Development workflow: plan, write issue spec referencing, design, test-driven development, review, deploy, and post-deploy, quality gates, and then governance. This constitution supersedes all legacy practice documents. It almost looks like a legal document, doesn't it? It's a ratification, last amended. I mean, very cool. But let's move on to actually building the application. So let's start a new chat here. And if you remember, if we go back to our Spec Kit documentation, it gave us sort of the 3 steps that we needed. So create the install specify, check. Create the spec, use the /specify command to describe what you want to build, focus on the what and why. Great. Let's do that. All right, so here's our prompt. You're designing a web application called the URL list. Your purpose is to let users create and share a collection of URLs. The user should be able to create a new empty list, add URLs through an input field. The list should display all of the URLs, and then they should be able to share those URLs is essentially the rest of it. Now, there's a ton of functionality missing from the actual application that I showed you. And the reason for that is because we don't want to try to do too much. I want a very baseline working version of this thing, and then we'll add features. Working iteratively with AI is very important. Now, the other thing that you'll notice is that I have said nothing here about how the application is built. I've not specified that it's Next.js. I've not specified the database. I've not specified the UI framework. And that is because this is an important part of the process here. You can see that you're specifying what you want to build and why you're building it, not how you were doing it. We'll get to that in the next step. So, you ready? Let's send this, and then I will come back to you when this is done. Okay, it's finished. Now let's walk back up here and let me show you a little bit of what the chat did, because it's important to understand how Spec Kit works. So we got the spec, which you can see here. I'm just going to keep this because what else would we do? Before we actually get into what this file does, let's go back up and take a look here. Essentially what it did was it executed this command here. So it looked at the specify scripts PowerShell create new feature PS1. So let's jump over there and take a look at that. Scripts, create new feature, PS1. And then instead of me trying to parse this, let's do this. So this PowerShell script automates the process of creating a new feature specification in a Git-based project. When run, it expects a description. The script determines the root of the Git repository, ensures that a specs directory exists, calculates the next available feature number by scanning existing directories, and then generates a branch name based on the feature description. So it's essentially setting up all the scaffolding for us, because as you remember, the spec is supposed to be the artifact that's important. So what it's doing is creating the folder structure, and then it actually moved us to a branch. It created a branch for this feature, 001 design web application, named it and everything. So if we look here at our specify, let's see here, we have a new folder, specs. Here it is. And then inside of that, here's our spec.md. So as we move through these different features that we're going to be adding, we'll get a different folder and a different branch for each one. So you see, it's giving us this really nice opinionated workflow for how to work with things, and even moved us to the right Git branch. I love that. All right, what's next? Next, it's going to want us to create a technical implementation plan, which is the /plan. Use the plan command to provide your tech stack and architecture choices. So this is where we're actually going to tell it what technologies we're using. Actually, hold the phone. Before we do that, we really should look at the spec and see what it generated for us. So let's do that. Let's look. I like to look at Markdown in the preview here because it's just a lot easier to read. So here is our preview spec. And as you can see, with spec-driven development, you get quite a lot of prose that you have to read through. And this is one of the areas where I'm not quite sure how we deal with this. It seems to me that as a developer, I would not want to have to do this. I just want to go through and build the project. But someone has to write the spec, and we need to make sure that it is correct. So I don't have an answer for you other than I feel the frustration with I don't want to have to read specs. I don't want to spend my time doing that. I don't have an answer. We're going to try to get through this one though quickly here. And I think maybe the answer in the meantime is move in small steps so you don't have as much spec to review as you go. So it looks like here for AI generation, this all looks like sort of high level instructions for the model. It doesn't really have anything to do with my project here. It's specifying very broad constraints. Here, though, is where we get into user scenarios. So here's the primary user story. This somewhat resembles our prompt, but broken out into an actual user story here. If you've never seen user stories or acceptance scenarios before, these are well-trodden sort of philosophies about software development workflow that you can go read up on. I do think that if we're going to do prompt-driven development, we're all going to have to know a little bit more about these things. And I'll be the first to admit, I don't know a ton about them. But each one of these just sort of defines how the user would interact with the application. In fact, if we start here, given a user on the application wanting to start a collection, when they choose to create a new list, then an empty list with a placeholder name and a draft status is created and visible to them for editing. This goes on and on here. And then there are edge cases that this is quite interesting. These are the things that the LLM helps you think of that you didn't think of before. Adding the same URL multiple times. How are we going to handle that? What if the URL is very, very long and needs to be truncated? Let's see, metadata fetch failure. So when it tries to fetch information about the URL to display to the user, what happens if that fails? Slug collision due to concurrent creation. What if two users try to create a list with the same name at the same time? How are we going to handle that? Again, I find this super helpful because I don't think of these things. I don't think of them until they happen. And then they're just bugs. And the LLM's kind of helping catch all this stuff up front. And then down here, we have functional requirements. And when I make my PRDs, they look more like this. So this FR-001, functional requirement 1, system must allow a user to create a new empty list in draft status here. So it just sort of distills down everything that's up here into even more refined and very concrete syntax. All the way through, what do we have? 28 functional requirements here in this first one, which honestly feels like a lot. If I was going to do this again, I might try to scope this even more. Then there's entities here because we are involving data, so we need to have the concept of entities. So we have list, a URL entry, a slug. This is essentially what the database tables are going to look like in written word. And then the acceptance checklist, content quality. How do we know? Focused on user values and business needs, written for non-technical stakeholders, because we're talking about the spec here, not the code. Just going down, execution status, kept updated by main during processing. So you can see here it's gone through and checked off everything. Review checklist passed, pending clarifications. So it says it needs clarifications. Clarification required. So if we see here, it says, needs clarification. Should duplicates be blocked or merely flagged? Needs clarification. Logging, retention, compliance requirements. So normally what we would do is go through this spec and provide all of these clarifications for the model. But again, for the sake of time, what I'm going to do here is say, please resolve all needs clarification with smart assumptions. All right, so the next step here is to create the plan. So let's create a technical implementation plan. So here was our plan. We'll just make sure that the spec is being passed in along with the context as it is, and then we'll send it. All right, we got a bunch of files there. This is quite interesting. So let's go through and look at what we got. So the first thing that it gave me was this data model, which literally defines the data model for this application. It's just like the tables, and then it even gives you the SQL down here that it's going to need to do that. So that's what this is. This right here, this lists.md, appears to define the API. So you can see here a get to this endpoint with this response. Here's what it looks like. So you're defining the endpoints and the responses up front so that you know how to handle them. The LLM knows how to handle them, the actual application. Then we got this research where it actually went through and researched my application to look for how the application is currently structured, what we're currently working with, so it knows what to do going forward. So you can see here, it looked and did technology stack confirmation, session bound creator identification, use an opaque creator session ID support in an HTTP only cookie for first list creation. Interesting. Okay, so it's binding the session to the current user because there is no login at the moment. So that's an interesting way to handle that. The slug generation, the slug is the unique URL that each user will get for their list. The metadata fetch implementation just goes on and on here. And then the quick start here. So this almost looks like, oh, is this for me? This is for me. So I need to run all of these things in order for this to actually work. Very interesting. And then it created this task list, and I'm not sure why it created this because if I'm not mistaken, this file simulates tasks output, follow TDD test before implementation. Because if I'm not mistaken, there is a tasks step. Use tasks to create an actionable task list. And let's go ahead and do that now. So let's go ahead and keep all of this. And let's use the task command. And what I noticed before was that even though I specified in the context the file, it went through and found all the files that it needed anyway. So what I'm going to do now is just pass in tasks with no context because I want to see how Spec Kit handles this. All right, it's done creating our tasks, and it was able to go through and find all of the context that it needed. It did that right there. It had no problem with that. So apparently you don't need to provide any context. It will go get the context. So let's take a look at the tasks here. Again, I want to go to preview because it's just easier to read this way. So it's referencing all of the other files here. Here were the inputs. All these files have been created. A legend, phase. Okay, initialize test config. So you can see here, the thing that pops out to me is that we're absolutely doing test-driven development because it's just starting with tests. So it's going to create that first. Then it creates the database connection. I'm assuming we're doing test-driven development. Adding a slug, adding metadata, configure SHADC and UI pipeline. Create an initial example for the env file. Database schema, models migration before tests. Okay, so it's going to create the database schema first. Here we go. Contract test, API shape must fail initially. Interesting. I guess that's because there's nothing there, and so they would fail. Curious though why it didn't mock. Integration test, user scenarios fail first. Interesting again. So these are all user scenarios here. Core implementation, failing test drive code. Implement route handler. The get, the post, the patch. So at this point, it's actually writing the code. Oh, I see. It's using the failing tests to actually write the code that it needs for the test to pass. That's wild. And then, okay, so then we're down to UI server and client components. Integration and infra enhancements, polish, dependency. Like there's a lot here. I mean, look at it. We would have to read through all of this. Execution guidance, tasks. Here's the plan. I mean, there's just so much here, and I don't have an answer for how we're supposed to handle this. But for the sake of time and like actually getting to something here, the last thing that we need to do, according to the docs, is all we have to do now that we have this task list here is just say implement. And for this, I am going to mention that tasks file, the task MD, just like that. I'm just going to say implement tasks. And I'm going to let this run. I'm going to go get some coffee. This is going to take a while because there is a lot of steps for it to go through. And then we'll come back and we'll see what we've got. See you in a minute. That took an hour. Now, there's a couple reasons for that. First of all, it stopped quite a few times. I'm going to scroll back up here so you can see sort of what happened, but you can see it's asking me for clarification on things. And you can see I'm saying proceed, continue, proceed, right? There's a lot of this. And in this way, it feels like I'm using GPT 4.1. And this could be because I'm using GPT 5, and I'll specify why I'm doing that in a moment. I kind of wish it would have continued on its own here, but it did do a very good job of sort of stopping and asking me for clarification when it thought it needed it. We also had to go through and get the database working. So at one point it stopped and asked me to just run a migration, which was pnpm migrate. And that didn't work because the database connection information wasn't set up. So I had to fix that. The rest of it did on its own, including fixing its own tests. And it insisted on fixing all tests before it would continue on, which it did. All tests are running. And so now I think the best thing to do here is to just run this application and see what we've got. So let's keep these files. You can see it wrote 2,000 lines of code and 59 files were changed. So let's keep this code here. And then if we take a look at what we've got quite a few files. So I just want to check the structure to see how it structured the application. It looks right here. This is how routes are structured here in Next.js. But again, all of this looks really good. I like the separation of concerns here. Very interesting how it's got this all broken out. But of course, the important thing is whether or not it runs. So let's go ahead and try that and see if it runs. Okay, this is running, but it wasn't necessarily easy. So it ran into an error where it was trying to use it was trying to mix slug and ID in the path, which you cannot do in Next.js. If they're both under the same path/variable, then the sub ones need to be the same. So it got stuck there. I had to manually fix that. And then when I went to the page, there was nothing there but the next landing page. So I had to fix that as well. There was just no landing page. So not perfect, but let me show you where we are now. So this is what we got from all of that. It's a minimal prototype UI. After creating a list, you can add entries, set a slug, and publish. So let's create a new list. It creates it. And then let's just add some items here. That doesn't appear to work. Oh, it did work. Okay. And then let's add another one. Okay, so this is working. Can you edit these? Does look like you can. All of the data updates appear to be working. The slug, let's do a test. It's checking to see it's available. Okay, so it's checking the database. There's a lot of functionality here. A lot of functionality. All the database is wired up. Let's publish this. And now it's live. I don't think we can click here. And there's no way to see the URL. The URL is gone now, so I don't know what the URL is. If we go back home, then we don't see it. So there's a lot of features that we need to add here, but we have a very robust scaffold for the application, a very robust start. The application is structured quite well, and we have a complete test suite. So now we would add new functionality and we would start all over again with the specify and plan phases. But before we did that, we'd check in this branch and then move on to the next branch of functionality. So that is the Spec Kit from GitHub at a very high level. I think it's still early days. This is one of the first frameworks, I think you could call it, for LLMs I've seen that is a very opinionated workflow, and it seems to generate really, really concise, nice code. Like if we look at this, we can see it's added interfaces here. They're all at the top, all of our exports. It's just structured well. Now, one of the things that I want to address is why I didn't use Claude. And in talking to the authors of Spec Kit, what I found using Claude is that Claude would generate thousands of lines of spec and then even more code. And so it would generate 3,000 to 5,000 lines of spec for this prompt and then 15,000 lines of code. If you look, I think we generated 2,000 lines with GPT-5 And the reason for this is there's a hypothesis that Claude generates code, a little too much code. And this is part of its training, and this is its downfall. And so GPT-5 is a very capable model and also doesn't over-generate code, because 2,000 lines already is difficult, if not impossible to review. 15,000 lines is flat out impossible to review. So that's Spec Kit from GitHub. Check it out. Let me know what you think. A bit of a longer video here, but as you can see, a lot to get into if you really want to understand what it's doing and what's going on. Thank you for watching. And as always, happy coding.